Alright, so hey everyone, thank you for attending. Today I'm going to talk about trusted types, or how we deal with XSS, a specific thread at Google at scale. So first, if I quickly introduce myself. So I'm Kian, I'm a product security engineer working at Google based in New York City. I'm mostly interested in anything related to web, as you can see, which is going to be the talk today, but also crypto, fuzzing, and various things. Outside of work, I can actually do some open source, anything related to security, so mostly OWASP related tools. When we at Google, I work in the information security team. So we work mostly on pretty much on all the products. So we're talking about hundreds of products, billions of users. We're lucky to see a lot of different things. And we like to say that we work on security by construction, meaning that we're trying to develop the right platform so that our software engineers don't have to worry about security too much. So they basically have it enabled by default. The goal of the talk today is to give you the right tools so that you can pretty much apply trusted types, which is a web platform, for your own products. The way we're going to proceed is, first, I'm going to come back on what a XSS is. Maybe a lot of you might already know about that. Before introducing trusted types as a technology. And then I'll first start by talking about what happens if you want to use it on an app that you're building from scratch, which is probably the easiest case. After which we're going to talk about a just rollout on an existing application which doesn't have it by default. And finally, I'll try to see a few patterns that we generally meet when we try to enable trusted types, so that you have a few examples in mind. But first, when it comes to XSS, so a cross-site scripting attack, I'm going to be brief, because I'm assuming most of you are familiar with that, happens when a user input is generally concatenated with some code. So it's a pretty common vulnerability, unfortunately, on the web. And what's going to happen is, as you can imagine, that specific code is going to be interpreted as a script. So a malicious input, right, can be injected into the victim's browser, meaning that from there you can assume that an attacker can take fully control of the user's session. So it's really up to the creativity of the attacker at this point to see what they can do. It could mean stealing the user's cookies, hijacking the user's session, or just repurposing the page. That's why we kind of like to talk about RC of the web. So the vulnerability itself is critical. How we solved it at Google, not really, unfortunately. So as you can see here, this is our VRP program, so our in-house bug bounty program. So that kind of shows all the findings that we're getting. A good part of them are web-related, but within the web ones, the XSS represents a big portion of them. So we're still dealing with these threads. There's different types of XSS, but I'm going to focus on a specific one, which is probably the trickiest one to deal with in general, the dumb XSS ones. So I'm not going to mention the reflected and stored categories, but they also exist. So when it comes to dumb XSS, what happens is it's a client-side attack, and it is happening mostly because of certain dumb APIs which are not secure by default. So all these dumb APIs would allow to perform sensitive manipulation of strings, and the problem is that they're just taking in strings, and they're going to interpret it as code no matter what. So if you don't really worry about it, you can be sure that these strings can be used to leverage an XSS. So you have a simple example here with the inner HTML, which is one of these dumb APIs, being used to inject a variable foo. And as you can see, if foo is controlled by the user, you get a straight dumb XSS out of it. And so it could be any JS being executed in the browser. So you would think it never happens, but you'd be surprised. These dumb APIs are used a little bit everywhere, sometimes when they're not necessary. So you can find them pretty much across the entire application when you're in a pretty bad stage. And you might wonder, how many of them do we have? Well, we have a lot. There is a whole set of APIs which would allow to execute this attack. So more than 60 if we really had to cover all of them. The attack surface is pretty broad. And that's where trusted types comes into the picture. And so this is probably the most critical slide of the presentation. The idea behind trusted types is fairly simple. The whole idea is you want to make sure that the developer is conscious of the usage of these APIs and well aware, right, of the strings that they're inserting whenever it's happening. And to make that a much more conscious decision, what's happening is trusted types is requiring, instead of strings, type objects to be passed into these APIs. So for example, instead of giving a simple string for this inner-HTML API, we're going to require a trusted HTML, and so on and so forth for all the other APIs, right? So there is like families of trusted objects, and they're all going to be passed to the .sings. And this way, you can be sure that when these APIs are used, well, the decision is clear. You might wonder how we are enforcing this, and that's where there is a backend component to trusted types, which basically consists in enforcing it to the browser. So the only thing you need to do to enforce trusted types is pass a specific header from the application to the browser. So it's a specific CSV header, which is static, so fairly simple to implement. And what it's going to do is that it's going to instruct the browser to block the execution of any of these APIs if a type object hasn't been used for it. So after providing this header, you can be sure that none of these dangerous APIs are going to be enabled with a random string. And that's supported by most browsers today, so we inject that into Chrome, but it's also going to be available in all Chromium-based browsers. And in fact, even if the browser doesn't support it, trusted types is still going to be useful, and we're going to see why later. I'm going to expand on that. So now, if we want to see concretely how it works, when you create a trusted type policy, so the first thing you do is you establish a policy, and as you can see in the top snippet, most of the time we have a sanitizer which is going to allow to handle the input, so you don't want to just convert the input as it is if there is any risk. So that's where we're making sure that we're stripping out any potential dangerous character. And then once we have that, we can just pass the trusted HTML, so that's the example, to the type object, to the API. And here the browser is going to allow that because it is complying with trusted types. So again, we're going from the former model where we had a simple value as a string passed to the image HTML to, again, a few more lines. It's not too complicated, which will allow us to provide a type object instead of a string. Most of the time, we recommend using save values, which is our in-house library that we developed at Google that would allow you to do that without really having to worry about implementing a policy. So it's just going to allow you to do the same thing, but in a much faster and shorter way, and you won't have to worry about any implementation issue. So the first thing we're going to look at is if you want to implement trusted types for an application, but from scratch. And that's the easy use case, where you don't really have to worry about a lot of existing DOM APIs in your application, right? So you're just starting from scratch, and it's pretty fresh. What you want to do is first make sure that you're abstracting most of the work before even thinking about trusted types. And so as we saw, there's a lot of APIs to cover if you want to think about that. And so ideally what you want to do is you want to use a recommended framework, which is going to be compatible with trusted types. So all these ones would be, which means that if you're using them, you're basically sure that they're compliant, they're not going to use these DOM APIs dangerously by default. Does that mean that you're safe? It doesn't. We still find DOM XSS even though these frameworks are used. And the reason is, even if you're using these frameworks, you can always inject the DOM XSS by simply using the DOM APIs yourself. So we only requires one dev and one bad day to introduce that line, and then it's kind of game over. So that's where trusted types still becomes critical. The idea is for a fresh new app, you just have to enforce it right away when you start writing your application. So by setting the static header, as we said, or we can add it with a meta tag, it's only a one-time effort. But what it's going to do is it's going to prevent the introduction of any of these APIs in your application, right? So if you enable it right away, when the devs are starting to write the code even manually, if they're by mistake, right, injecting one of these DOM API, it's going to get blocked right away, which means that they'll see it at the testing phase, so either manual testing or you want to enable it in your unit test as well. And so the execution should be blocked at that stage. On top of that, we also generally recommend to use the right toolings. And that's just going to make your life easier. It's not necessary, but it always helps. So save value was mentioned before, because it allows to write policy in a simple way. One good thing with safe value is that it also gives you the right philosophy. I guess that the library is very opinionated, so it's not going to allow you to pass any string to the APIs it provides. So the way the documentation and the APIs are designed is going to force a developer to basically think about trusted types from the beginning. And then if you want to shift left a little bit more, well, there is also static code analyzer, TSEC, that we also recommend here, which will allow basically to do what comes before trusted types, which is detecting all these dangerous patterns in the code in a static way. You can even integrate that as part of the CI/CD pipeline, so it should be very transparent. And the good thing is it's going to get rid of the easy cases. Obviously not all of them, and that's why trusted type is so useful, is there's a lot of tricky use cases that can only be detected at runtime. But for whatever can be seen before, TSEC should do the work. So that's pretty much it. If you're trying to do it for a new app, just using the right frameworks, enforcing early to prevent any regression from happening or any introduction of these APIs, and then a good static code analyzer as TSEC should allow you to do the job. So that was the easy use case. Most of the time what's going to happen is you're going to try to enforce trusted types for an application which is already existing, which means that there might be a lot of these patterns in the application when you're starting, and so you want to take care of that by following a specific methodology, and that's what we're going to focus on right now. So I wanted to come back on a few success stories that we had at Google doing that, because we've been doing that a lot and acquired some experience around this. But the first thing to see is what we're getting out of it. And so the promise that we're getting, the result that we've observed, is for with trusted types enabled for all our applications, we get to the point where we get rid of .xss. And by that I mean that once trusted types is forced to enable for a given application, we basically remove any .xss which is present, but we also ensure that there won't be any new one introduced in the future. So it's a very interesting result, and that's also a good motivator. What we've had so far is more than 400 applications enforcing it. Some of them that you might know, like Google Photos or BART, are also using trusted types. And we also made sure that for any new application, it is enforced by default. So we don't really have to worry about it through specific frameworks that we're using. One caveat though that I want to come back on is, so the goal of the talk is not to give the impression that enforcing trusted types or adopting trusted types for an existing app is easy. It's generally the opposite, it's very difficult. But I think the whole point for us here is to say that it is definitely worth it. And the reason for that is because basically first it allows to get rid of .xss, as you saw, which is a pretty great vulnerability, and doing that at scale, that's pretty necessary in our case. But in general, just to allow them to have to worry about that too much, to code reviews and constant reviews. On another hand, the other big advantage of trusted types is you don't necessarily need to enforce it to get to a stage where you've achieved security. What's happening is, as you are making your app compliant by getting rid of all these dangerous patterns, you're just increasing the security posture of the application. So that's just happening over time, which means that even if the browser doesn't support trusted types and you don't reach enforcement, by just making it compliant, you've already probably got rid of a few .xss along the way. So now this is said, the process that we follow when it comes to a rollout generally consists in a few steps. The first one, the report on this step, is basically the idea of enabling trusted types but not enforcing it. So it's a little bit like CSP, some people are familiar with that. What's going to happen is the trusted types header is going to be set, but in report-only mode. So whenever there is some offending code being detected, instead of blocking it, the browser is going to allow it, but it's going to send a report to one of your endpoints. So you just have to establish the right endpoint. And it's a report collection phase where your users are going to browse through the app and generate all these violation patterns. That's going to give you an idea of the number of DOM APIs, these DOM APIs that you're using. Once you have that, you want to analyze them, and that's the, I guess, triage phase, where you're going to see how many you have. That's pretty much where you have an idea of the effort required. If you're lucky and there is nothing, you're pretty much at the same stage as a fresh new app, which means that you can just enforce it right away. Almost never happens with an existing application. What's going to happen is most of the time you're going to get a lot of violations, and what you want to do is try to see how you can categorize them. Again, they might be easy to fix if the root causes are simple. But that's where you get that idea of how much effort is required. And then comes the most important step, which is basically the refactoring of your code. So once you're there, you have all your violations and your reports that you collected before. You can just try to analyze each one of them and see where the offending code is and update it so that you basically get rid of it or fix it. That's where you might fix some vulnerabilities along the way. Once you've done that, you just want to wait for your users to just browse again and see if there's anything you've missed. So maybe 1 or 2 weeks should be enough. If you're seeing something else, you just want to repeat the previous steps, meaning you're coming back, trying to see if there is a violation. If there is one, refactor it, and then wait again. And if you wait long enough and you don't see anything else, you're ready to enforce. So these are all the steps. Again, the most important one is going to be the refactoring step. And it's all about analyzing your violations and being able to fix them one by one. And that's why I wanted to focus a little bit more on that and expand on how you want to perform the investigation. We're used to do that generally at Google. I guess that there is a methodology that could be followed that would allow to do this fairly simply. So if we look at what happens when you get a violation, this is what you're going to see if you open your Chrome console. And so look at it, you're going to see some errors appearing with the call stack, so meaning what happened exactly to trigger the violation. If you look at the network tab, there's a request being sent to your endpoint, and that's where you have a few information right along the request, and that's what's interesting to us. So if you look at what's happening, we're sending a few fields. The first one is the document URI, which tells you on which page the violation happened, right? So that's going to be super useful if you know your app well, which generally you do. You can tell where there is some offending pattern, right? Maybe even guess right away which user workflow triggered the violation. Then comes, if you're really lucky, and these are not guaranteed, the line number and the column number with the source file. So if you get all of that, it's pretty much over. You know which file is causing it, where exactly is the line that's causing it, so you can quickly replace or wrap up that specific DOM API. Most of the time what's going to happen is that these fields are not really available, but the one that's guaranteed is a script sample. And that's why it's my favorite one. This one is always here and can 99% of the time allow you to find a violation by itself. So it contains too much information. The violation type, which is going to give you the DOM API that triggered the violation, and then the input sync, so basically which input was introduced and triggered that specific violation by the browser. So if we summarize the process, what's going to happen is first you want to do some code analysis using the script sample field that we just saw, which is going to give you two information: the violation type, so let's say it's an inner HTML violation, you know that you're looking for inner HTML somewhere, and then the input sync. By using that, you might be able to do a simple grep. Honestly, that's been working great for us on your source code. And you might find right away that there's a static string being injected somewhere. You got it, you can just remove it or fix it. There might be some code re-injected into your DOM, that's also a possibility. So that should solve a lot of the existing violations very quickly. If you still haven't found it, which is possible, you might want to start doing some runtime analysis. And in this case, what's going to happen is you're going to go directly in your browser and try to reproduce the violation yourself manually. So the document URI, which gave you the location, is what's going to be useful here. So you know on which page you want to go. And then by simply going on that page, ideally you want to trigger it, so it might be execute if you use a workflow to see which one is going to enable that violation to happen again. Once you have it, as we saw in the console, you have the full call stack. It's much easier to tell where the violation is. So 99% of the time, that should allow you to get your violation. If you haven't found it yet, there might be ways to infer where the violation is happening. So a lot of the times it might happen in a dependency, and we're going to look at that later. That makes it a little bit harder. But again, you're going to develop some instinct over time, and it might get easier and easier as you'll see it. So if we concretely want to look at some common patterns that we often see when dealing with trusted types, I feel like we want to categorize them in two different buckets. The first one is when the violations are happening in your own code, and that's the easy use case again, because here you can just fix it right away. You control your code, so whatever offending pattern you're finding can be modified, and when it's happening in dependencies, and that's a tricky use case that we're going to talk about later. So if it's in your own application code, then again, it depends on what's happening exactly. If you're using any string, right, to render it on your page, ideally you want to escape it to make sure that you're safe, not triggering any potential XSS right away. So that's the first reflex you want to have. And it's just to prevent, right, the exploitation of the string. If the string is not supposed to be rendered as an HTML, no need to use the inner HTML API. So a lot of the times these APIs are used and they're unnecessary. Again, they're increasing the attack surface. So you can just replace them by harmless APIs, which would do the job as well. If we are talking about a static string, you can be sure that there's basically no risk. And so in this case, you can use a policy, a justice policy right away. So it could be like an inline policy that you're writing or using safe values again to mark it as a type object, as we said, and that's going to allow it to go through. If you can refactor it for any reason right now and you want to enable trusted types and not be blocked by that, what you want to do is do what we call legacy conversion. I don't recommend doing that too much. Well, the idea is you're saying, I'm not sure what's happening here, so I'm going to let it go through. And it's kind of a risk, obviously. And I'm going to look at it later to see exactly what's happening here. So legacy conversion is the last resort when we want to enable it quickly and there is no immediate solution. A better version of that would be a reviewed conversion, where here you know why it's safe. And so you're not going to update the code for now, you're going to refactor it, but you can just let it go through with the right reason, explaining what's happening, so that if the dev looks at it afterwards, they can tell that this pattern is safe and that there's no risk in that spot. So this is all for the first party code. When it comes to dependencies, it's a different story. So what's going to happen is for a lot of your applications, you're going to end up with a lot of different dependencies, which will contain violations, and that's a pattern that we've been observing consistently. And the problem with that is all these dependencies are going to be pulled out in different ways, right? You most of the time will have to patch the violation or refactor it on the dependency source code itself. And so the ideal use case is if you can patch it upstream. And so we have the code on GitHub, so just submit a PR is what we always do. The benefit of that is obviously you're helping everyone by patching the violation, and so it's kind of a community work by just making all these libraries trusted as compatible. But it also allows a cleaner integration into your own app, because then you only have to upgrade your dependency to benefit from the patch. In practice, it doesn't work like that. What's going to happen is a lot of the times the PR is pending for a while because we're discussing back and forth with owners, which makes sense, right, about how we want to do that. Do we want to use a feature flag? Is it going to impact the library? So that can take some time. Besides, it might be difficult to upgrade your own library for any reason, right? Or it could also be a transitive dependency, and it's also a little trickier in this case to pull the patch. So what we do, and we recommend, is you want to make sure that your product is safe as soon as possible. So set up like a private fork, which is a temporary solution that allows you to patch the specific violation, especially if it's an XSS that's exploitable right away. And then wait for the PR to be submitted to eventually pull it from upstream and fix that. So that again should work for 90% of the cases when you're dealing with a third-party library. But you might be in a position where you're not able, again, to have your private fork, and the reason being you just can't refactor that specific code. The library doesn't rebuild. If you do that, you're breaking a lot of tests. There's no way to ensure that it's easy to patch. And in this case, we recommend using what we call a default policy, which is kind of a fallback mechanism that we're using. So what is a default policy? It's a trust set policy that is a little bit special. It applies for a specific violation type to all the inputs on the application. So for example, the trusted HTML violations, let's say that you enable a default policy there, what you're going to do is that whenever there is an inner HTML call, all the inputs getting there in the application are going to be allowed, and ideally you want to apply a layer of sanitization around it, so you're just letting them go through all of that. Obviously by sanitizing the inputs, you might break a lot of things in the application. So that's not what we're trying to do here. And so we're just going to use a default policy in our case to fix specific violations, which are dependencies that are hard to refactor. And that's where you're going to scope it the right inputs, right? So these are pretty common jQuery violations patterns. And so let's say you want to fix these ones, you can't really patch jQuery that quickly. What you're doing is you're just writing a default policy in your application that says, for these specific inputs, just let them go through because you already reviewed them and assume that they're not going to be dangerous. Again, they're static strings in this case. For everything else, according to the spec, what you want to do is, and that's very critical, you want to return null, which means that you're basically not silencing any other violation in the application. So if it's not these inputs that you're encountering, well, just trigger a violation as expected. You especially don't want to silence them if you're in this position. So the pros of this approach is it allows less refactoring, obviously, because you're just not touching the actual code, you're just allowing the input to go through, so you haven't really fixed the third-party library. And you're also not blocked by the violation anymore if you want to enable trusted types. The problem with this approach, and that's where the double-edged sword, is you're not actually offering protection for any browser in this case, which doesn't have trusted types, precisely because you haven't refactored the dangerous code, which means that the same code is running, you're just letting it go through. So as I said, when you're doing the refactoring, you're just increasing the security posture of the app. Well, not in this case. You're skipping that step. And again, if you're using a sanitizer, that sanitizer might at some point be vulnerable, in which case you're just triggering a new vulnerability in your policy and your application as well. And finally, I mentioned the idea of returning null at the end of the default policy. If you don't, you're going to silence all the violations in your application, which is going to be trusted as really hard to debug, and it's generally not the case. So again, whenever you're using default policy, there's always the risk of making that mistake. So it's one risk that comes with that to have in mind. So to conclude, I guess that the goal was to show that DOM XSS and XSS in general, the DOM XSS specifically is still a prevalent problem or threat in the web security industry, so it's still something that we're facing. Trusted types is probably the most robust layer of defense that we have to be against it to be able to fix it at scale. The deployment itself, especially for existing application, is not easy. Most of the time it's very difficult, but we believe it's worth it, again, because the result we're getting every time is no more DOM XSS. I mean, they pretty much resolve once and for all. And on top of that, the path for enforcement again and all the refactoring just increases the security posture and solves a lot of issues when happening. There is this issue of dependencies when you're using trusted types, and so again, it's definitely possible to manage it as we saw. So there is ways to fix all the violations having dependencies. And finally, one thing that I'm also again emphasizing on is when you're patching these dependencies, I highly recommend to do it on the public repos. It's just by working together that the whole idea is to make the trusted types community stronger. So it's just going to help everyone in the ecosystem to have more and more compatible libraries. That's it for me. I'm going to be here if you have any questions. Thank you.